This is the climbing the wall problem that we did together in class today as we explored rational functions. It says the climbing wall is a popular event at the Springfield Fair. The wall is 100 meters high, but Bart can climb it at a rate of 8 meters per minute, but other participants climb at different speeds. Complete the table to show that the time it takes to reach the top of the wall depends on the climber's speed. Then plot the points. So you notice here that at various rates it would take various amounts of time. At 0 meters per minute, we're not going anywhere. So really time is undefined. But you might think, well, wouldn't that just mean 0 minutes if it's 0 rate? No, because you're saying how long does it take to climb the wall? Well, if you don't go at all, it would take an infinite amount of time to climb the wall, not 0 amount of time to climb the wall. If you think about it, we're actually dealing with the situation distance equals rate times time. So if I know rate, I know distance as 100, I would have to divide 100 by my rate to get my time. So I actually have this equation here, that y, or f of x, equals 100 over x. So in order to figure out the time, I have to divide the distance by the rate. So if I go 2 meters per minute, and I'm going 100 meters, then it'd take me 50 minutes to climb the wall. And so that's how we get all these numbers. It's 100 divided by the rate. And when you do this, you get this graph that's the part of the graph that's shown in black over here. Now, the part of the graph shown in blue isn't something we actually did in class, but that would be what would happen if we put in negative values for rate. Now, we'll talk about later whether that makes sense or not. But this part of the graph, the black part, is the part that we would get. So we're going to look at some characteristics of this graph. First of all, does the function have a y-intercept? Well, when you look at it, the way I drew it, it doesn't so far, but if we made x small enough, would it have a y-intercept? So let's think about that. Remember, to find y, we have to take the distance and divide it by x. And so if we wanted to find a y-intercept, remember that x would have to be 0, but if x is 0, then we have an undefined quantity, so y cannot exist when x is 0. So that's what we talked about earlier with our first entry in the table. When we're not going anywhere, we would take an infinite amount of time. That's undefined, so we don't have a y-intercept. Basically, the graph just runs along the axis and just keeps getting more infinitely big as x gets closer to 0. What about an x-intercept? Well, an x-intercept means that there would be some rate that would allow Bart, or whoever's climbing the wall, to climb 100 meters in 0 amount of time, because the x-intercept occurs when y equals 0. So is it possible to climb the wall in 0 amount of time? No. Even at the speed of light, it's going to take a little time. It's not instantaneous. So we also have an asymptote along here. So notice these are called asymptotes. I labeled these, that's the answer to the last question, so we won't really need to answer the last question. What about the whole graph? You graph this, if you put in f of x equals 100 over x, this is what your graph looks like. To find the domain and range, notice that I would look and see what possible x values I have. Well, I could actually put in any positive or any negative x value here, except 0. X can't equal 0. I could also put in any positive, I could also get any positive or negative y value, except I can't get 0. So we would say all real numbers, or negative infinity to positive infinity, except for 0 for both x and y. Does the entire domain and range make sense in the context of the problem? You could have a negative rate. That could mean positive rate could mean the speed climbing up, and the negative rate could mean the speed climbing down the wall. But pairing up negative rate with negative time doesn't really make sense. So in this context, it would only make sense to use positive values for rate and time. We could pair up negative rate with increasing time and basically, go back. We would have a different type of graph. It probably would not be a function. Mathematically, then, we say that x and y are asymptotes. The remainder of the worksheet then is to be done as homework, but there is a video that accompanies it. So as you go, there's periodic places marked with a star in the worksheet where it says stop and check your answers with a video. If you reach a point in the worksheet where you really just don't know how to answer a question, you can always use the video to help you get started as well.